Hello world, this is the next one. This is task 14. Okay, I'm gonna level with you. I've had to have a look at the solution in ZigZag because I wasn't sure, and this is when I realized it wouldn't run, and their example code is absolutely garbage and broken. So this is my first attempt to record this video. I hope they will be the only one, but I mean, there's a lot of things to get right. Let's just say this. So, task 14, let's go. Right, this question adapts the, can we be a bit bigger? Yeah. Adapts the skeleton program as they all do. A soldier ant, sure. A nest should contain the same number of soldier ants as working hands, fair enough. As a small food capacity, this is dumb. I didn't do that when I did my rehearsal, but like, you don't really need it because they don't carry food, but like, fine, we'll put like food capacity is equal 0. A new menu option to allow the user to place a predator into a cell in the simulation. Well, that's new. I thought we were talking about soldiers. Well, no, because we also have a new class. The simulation can have multiple predators, so that's the cue as to what you should change in the simulation class that wasn't specified in here. What annoys me is that they say a whole bunch of stuff in here, and then you look at what needs to be done here, and I'm like, well, surely something's missing, right? If you want the thing to do the thing that's written there, you need like a step in here that does something else. But no, they don't care. So yeah, that's why I had to look at the solution code to figure out when you need to do it. Okay, the simulation can multiple predators. So let's move out of the nest just like normal worker ants, but then they stay instead of patrolling. So again, I did it slightly differently than how they do it, because it's like they're just going to be patrolling from when they're in the nest. For me, if a predator is one of the neighboring cells of a soldier ant, the soldier ant should move into the same cell as the predator and change its stage to engaging. So there's a state to maintain this in the soldier ant, and we'll need to do getters and setters because those states are going to change based on stuff that the soldier ant class in that instance cannot know. That's the whole thing about encapsulation, is like what object has the information you need to do the thing you want to do. When engaging, the soldier ant should release pheromones which have 5 times the stank of a normal pheromone. Other soldier ants and worker ants not carrying food back to the nest should be attracted to this pheromone as the strongest around them. Now, if you do this stuff right, the whole point is that pheromones are pheromones. We don't know if they're tagging food. Actually, they never tag food, right? They tag, I passed here and I had food on my back. Which is annoying because actually it means the stronger the pheromone, the farther away from the food, because the pheromone the closer to the food decays. So that's fine. Like this is going to work as it were out of the box because we're just using pheromone tagging, and we're going to make soldiers also move by pheromones. The eventual outcome will be that a predator is overwhelmed. However, this does not need to be simulated. So we're kind of setting up everything for a big epic battle, but not actually doing the battle. So, oh my god, I am dreading this in advance. Copy, paste, rename. This might take a minute. Z14. All right, what do I need to do here? Well, I mean, let's do them in the order they're telling us, because like we can pretend we're following the thing. Predator class which inherits entity. We've done that a couple of times in videos before, so it should be a thing. New option 6, the main menu to allow the user to place a predator at any location in the simulation world. So for this, what they're not saying here, but what they have said but can have multiple predators, is that just like ants and nests and pheromones, we're going to need to have a private attribute that is a list of predators that are currently inside the simulation. So let's just do that now. So that's all good then. All right, let's go to entity, and below entity do a subclass. Class predator inherits entity. I mean, there's nothing here, right? I guess you just do pass, but like the class predator doesn't really, the predators don't do anything. They're just kind of in here, and then like the soldier ant could smell them and move towards them. I don't know if this is going to work, so I'm just going to kind of redef the constructor, but not really do anything with it, just call the super. So this is done. Cool, we're all happy about this. Now, to the meat of it, which is the simulation class. In here, we're going to want a print 6, oops, with a quote 6 dot, add lowercase p predator, otherwise it's the creature from the film, you know, with the night vision, infrared, whatever. It's a good film, it's a good creature. Anyway, so in here, just like we have a grid and pheromones and so on, we're going to have a cheeky little I need predators plural, and starts with as an empty list. Not changing this, adding the food, whatever. Setup nets. Okay, so just like we have add food to cell, we're going to have a add predator to cell, self, row, column, not quantity, just kind of where do we put them, and this we're just adding to the predators list. We append a new instance of the predator class that, because it inherits entity, will take row and column. Super. And then now that we have this function, this method, this public method indeed, we can just go in here, yeah, the choices, the choice menu and stuff. In here we go elif, choice is equal to 6. We are going to this simulation add predator to cell, except I can't do this just yet. Row, column, I've kept not defined them yet because I want row. So I don't know, is it like because get cell reference, if that breaks you're gonna pass zeros, but the point is that like the rows and columns start at 1, so 0 0 is not valid. So by initializing them here you just make it like break later rather than in the I don't know, rather than, you know, just breaking whatever. So I'm just gonna, I'm not doing initialization, but I am doing row column is equal to get cell reference. This will give me a row and a column. Make sure this is when you could, I've spotted it was a mistake when I rehearsed it. I didn't take too long to debug it, but I was quite frustrated because that could have taken a lot longer. Don't forget your bracket, because this is going to work, but sometimes you're going to test something like get type of end equal soldier, and if you don't put the bracket you're comparing a string with like a method of the end class. I need both my hands in the right place, so don't forget your brackets is what I'm saying. So here this is the new choice which will ask the user for a cell reference using the dedicated static method, and then chuck a predator at that cell. So far so I don't know, good, because like we can't tell. Well, actually, confirm to user the predator has been placed. Let's confirm to the user. We're going to print an f string and saying predator added at, and I'm going to row column. Super. Let's just check this if that works, right? Kind of up. Number 1, add predator 3. And then we can't see it because we've not changed the display function yet. So you know what, whilst I'm here, before I move on to the actual soldier round, fine, okay, beep at me, sure. Before I move on to the soldier round, I will go into get, Christ. It's class simulation and it's get details, I think. Yeah, get details. There's the area details, which, you know, this, yeah, we've changing this function in a bunch of the tasks when we have to support new types of arms and display them. And this, I mean, super annoyingly, this does all of the same thing. But I mean, the code that is common to those two methods should be like in the same method, and then you get one that calls it on the whole grid and one that calls it on the subsection of the grid. But yeah, whatever. So in here, if after the food, I guess, fine. All right. So if the predator list is not empty, which I do with if self.predators, because empty list is falsy. If we have predators, we're going to need to iterate over that list. Copy in. So it's always the same thing. We keep things in loose lists that are apparently unrelated, which means that to figure out if they are in the same place, we need to check if p in same location as the temp cell that we're using to iterate over. Then we're going to add to details plus equal. You know what, let me put some pipes like they do, because they're a bit consistent. Predator, pipe, space, whatever. Okay. Now that I've got this, they're not asking me to do it in get array details, I don't think. Yeah, right, update the get details. Look, they've not asked for get array details. I'm not gonna think. And so we'll do that later with the ants. And the problem with the ants, right, is again, because effectively the ants are either the queen or the workers, and the queen's always at the nest. There's a whole bunch of code that just goes over all of the ants and assumes that all of them are going to be workers. And now that we're going to have like, you know, specific, and those, you know, when there's more than one, like the flying or whatever, the forager or whatever, it gets a bit fiddly, because then you need to separate your worker ants from your soldier ants, and there's a whole bunch of methods that are just like, how many ants are in this cell? And you're like, well, I mean, it depends which type you want. So let's just run it again. Situation number 1, add a predator in free and display. look at this, right? It's, I should, what did I break? I broke it, I messed up with the, yeah, the \n should be in a different place here. Whatever. Okay, cool. So just, yeah, this should in fact be here, as in below. Here. Well, not there. Cool. Details for you then. Cool. Okay, we have added a predator to the simulation. Doesn't really do anything. A new soldier class, inherit sense, suitable attribute to store the current state of the soldier. State, probably, as a suitable attribute. Class aunt. Aunt and aunt. Aunt. Aunt? Well, that's your uncle's wife. Christ, there's a lot of aunt stuff. Right, okay, here we go. We're here. It's class soldier and oh, this is an old tune. Soldier boy, soldier and def in it. Yeah, this is good. I will also want self. I mean, did they say food capacity, whatever, to 5? Because they're never gonna get used in the code. But you know, they've asked for that, so we'll do it. And what's important is we have type event, I suppose, and that's a soldier. It's an equal, not a minus, obviously. You would have corrected this yourself. And we're gonna start as, if I'm being precious, it's a double underscore because it's very private. It's like fully private to the thing. It starts as patrolling, and then def get state self return self underscore state. Def set state self capital, keep it consistent state, and this is self dot underscore state becomes equal to state. Right, that's done. And also I'm going to leave just again, the classes are not structured super well, but this is where you would refactor. They're only asking us for like functional changes, never any refactoring. We have the, so this is all in the aunt class, which is super helpful, but there's a lot of like this one, the workaround choose cell to move to, as really a lot of really useful code, because this is to carry food back to the nest, but this does the random looking around for stuff, and then once it smells something, well, the next smelliest cell will go towards that. And this is the same logic that we want, except not in a if, we want it in if. You know, I'm going to take the whole thing, right? I'm going to, you know what? Poof. Actually, can I just, yeah, cool. This is choose cell to move to. I'm just going to paste this in here, but I am then going to, ooh, what have I done? That's better. And so in just, I'm going to delete all of this, right? So this now is just the bottom, the non-carrying part of choose cell. I can't do my air quotes if I'm not in the right frame. Better? Oh, the lighting's a bit better now. I don't know, it depends whether you're on some sunlight or... Okay, so we've done some of what we wanted to. Soldier ends, inherit sense, suitable attribute, we get this. Any required method in the base class to allow soldier and to operate as described. They have this sentence every time they ask you to change like create a new subclass, which I think might speak to the other languages. Modify the advanced stage and the update, and update hence feminine cells method in simulation class to operate as described. Do you know what they've not told us to do here is this bit, which is an S should contain the same number of soldier ends as worker ends. They've not told us that we need to do that as a task. Actually, the whole thing is a task, but like as an item, which means that if you just follow those instructions, it's not going to work. Okay, so this is when we set up nestat or something. Oh, this is now, I mean, I know it's good for you to have it big, but I just want it a little bit smaller here. Get cell details, add food to nest, no, not this one. Get array details, get strongest pheromone, and cell. Oh, yep. So neurons and cells, sorry, whilst I'm here, just say, don't count the, don't count the get type of aunt, bracket, don't forget this, if it's not equal to a soldier end, right? The type of ends are non-soldiers, which means that I'm also going to quick duplicate this. This is going to be for the rendering function, like the display, get details, which is the third bit, but still, what I've got here, and then simply we're just kind of doing this. Up, and here I'm going to soldiers Cool. And we made a function just like that. Okay, they were saying, let's do setup nest. This is where we create the workers, right? So if they want the same number, I'm just going to do the same thing, but except it's not going to be a workaround, but instead a soldier-round. Super, that part is done. Now, this is important. They want us to update on's pheromone in cell. Advanced stage and update. I'm going to do advanced stage first, because then this is going to make sense as to how we want to update the on's pheromone in cell. So, so advanced stage in the class simulation, right? Yeah, class simulation, def advanced stage. This is where we are, right? This is fiddly. So here, this assumes that all of the ons that are going to become called A in this big loop are workarounds. I mean, I guess there's some question mark about the queen, but like it doesn't really matter. For I don't know how it gets excluded for some reason. So, A advanced stage. This is in Hunt anyway, this is not in, you know, like our soldier Hunt will inherit it from Hunt, we're fine. Current cell, that's useful as well. All of that stuff, this is to transfer food to the nest, as we did in, I think the live one, in task 11. This is, what is this? If I'm carrying food, no, was it this again, yeah? No, if it's not carrying food, just pick up some food, and else, if this, lay some pheromones if it's carrying food, so we're gonna need to use this one as well. But anyway, I'm gonna go in here, and I'm gonna say if a dot get type of if it's a soldier ant, I'm going to pass for the time being, but else, if it's not a soldier ant, then I'm going to take all of this and indent it, right? So now we're only doing this for the ants that are not soldiers. Now, this is an absolute... this is where it gets quite difficult. Right, what do I want to do here? I think it's going to depend on the state. Is it? Shoot. If. Okay, so if, I mean, A dot get stat. So we know we have a get status method because we know A is a soldier ant. So if the get status is equal to patrolling, so if this ant is patrolling, it should behave like essentially behave like a workaround. It should just kind of look around, and then maybe if it smells something, this is the hard part. Or if it smells well, it's going to follow pheromones. That's fine. But if there's a predator in the neighboring cells, then it needs to move there. So you remember that when we did some ant motion for, I can't even remember, was it the forager or the flying or whatever, but like this is where the magic happens. And in fact, those two things, like the return value of get indices of neighbors, that's going to give us a list of neighbors, and then we have the strongest pheromone in the cell. So if it's patrolling, I'm going to say neighbors, like the Australian soap opera, becomes equal to, whoa, to this, which is slightly too big. Okay. Right, so I've got the neighbors, and also I'm going to do index. So the idea here is that I'm going to need to go over all of the predators in the, well, actually, maybe I'll, so if there are any predators, then I'm going to do 4p in self predators. Can I do in? No, I can't do in. If it's P, it's in the same location of the... Yeah, right, okay, cool, right. For each predator in the simulation, which in our test is only going to be one, so we don't have to worry about the complexity of this nested loop. And then for each of the neighbors, if P dot in, our good old friend in same location, as what? As, so neighbors, index of neighbor with the strongest pheromones, the indices of neighbors, those are the indices in self._grid. So those are indices of cell objects in the list that is the private attribute of the simulation class called self_grid. So if it's in the same location as self_grid at index n, then what this means is that there is a predator in this particular neighboring cell. Now, if there's more than one, we're going to be in trouble, whatever, but like it doesn't really matter, because if that's the case, we are going to say that index becomes equal to n. And then probably we're going to stop at the first predator, because the point is that if you get more than one predator in your neighboring 8 cells, then it's the last one that's going to be checked that we're going to go to, because index is going to take a new value every time. So since we can only aim for one predator at a given time, why don't we just break here, because that way at least it will be the first one that we found rather than the last one, if there's more than one. At this stage, I'm going to exit this loop. This is the neighbors loop, and then for the next predator, assuming if there's more than one, we will do that again. But if I'm then here, so at this stage, index is either the strongest smelling, like legit pheromone for other reasons, or we've just set it to like, oh, there's a predator nearby because our soldier needs to go there, which means that we can just pass choose cell to move to. Well, actually, sorry, not the same thing, because it's a choose cell to move to neighbors index. Okay. What else do I need to do? The rendering, I think. So this is gonna. Oh yeah, I want to. Oh, okay. There's more. Yeah. If we find the predator, then A, which is the soldier ant, needs to set state to. Oh yeah, because we have a patrolling here. Right? We only do this for the patrolling ants. Set state to engaging. And now that we've set the state to engaging, we're also going to print f string. You know, I might use just those. Soldier at the location of the ant in question, which is soldier ant, is engaging. Right. And then it moves. And here we're still in the soldier ant close, but there's an else. This is the engaged ants. We don't do anything, but I just want to print a little thing saying. Well, I mean, it's the same thing, right? F string soldier ant but instead of engaging is going to be actively engaged in combat with the predator. Fighting. Cool. Did that work? Okay, advanced stage, update, oh yes, update transformer in cell. Oh, update transformer in cell. Yes, so this is what I forgot, right? Because we need to lay some 5 quintuple strength pheromone, like the Uberstank, 5 times the strength of a normal pheromone. Well. So, if the ant is engaged, we are going to ask it to, and it's, where is it? Well, I'll be damned. Yes, self-update ants pheromone in cell bracket A. So this is a method in the simulation class that says, look at this ant and make it lay some pheromone wherever it is. And this add pheromone, updates and pheromone in cell. So what this does, this is a whole other thing, right? So it goes over the pheromone list, and if it finds one that is in this location and actually belongs to this hand, it just kind of reset it to its maximum strength rather than kind of adding some more. Otherwise, it will just add a new one. So it creates it instantiates a pheromone at this location and appends it with the new pheromone strength, and then what pheromone decay, whatever, doesn't really matter. So what we're going to do is that if a.get type of alt bracket, if that's equal to a soldier, we're gonna say a new pheromone. This is a local variable, but I'm naming. Can I spell strength correctly? No, I can't. Right, so I'm spelling it the same way so it's consistent, and we're just gonna. No, wait, sorry. I'm gonna initialize this. I'm initializing a private local variable called new pheromone strength, and in fact I am going to pass it to p-update strength, or when I create a new pheromone, also use this. Now this changes nothing so far, right? But if the type of ant is a soldier, we just say new pheromone strength multiplied equal, it's itself multiplied by 5. It's quite elegant because in like 2 lines of code and changing 2 argument parameters, syntax will kind of achieve the desired effect. Free feedback messages, move the patrolling to engaging, and when it's in combat with the predator, we have done this. Get detail to separately underline, that must be important, show how many ants, worker and queen, and soldier ants are in a cell. So what they mean by this is like don't count, when people say ant, when the get detail say ant, they actually mean workers or queens, but you can't just chuck the soldiers in there. You need to separately have those worker and queens are ants, and then have the soldiers, fingers. Right, so this is in simulation. Thankfully, we only need to do it in get details, but otherwise we'll be pasting code. Simulation, get details, right place. Cool. This is where we added the predator. Now, number of ants. Remember, get number of ants in cell. We have changed this a second ago. So it's not the soldiers, and we have a get number of soldiers in cell. That is for the soldiers. So same deal. After we've done the ants, we are going to say. No, I just call it soldiers. Is equal to cell dot underscore. No, not underscore. It's a public one. Get number of soldiers in cell, in temp cell, and oops, not colon here. Obviously, if I just soldiers, meaning soldiers larger than 0. Well, fine. I'll just put larger than 0 so it's consistent. So if we have soldiers, we're gonna append to the detail string a little bit of the old f string. And consistent here, pipe space soldiers colon space. Why is this wiggly? Oh, detailed, because details. Yeah, that's right. Soldier, and this is just soldiers. Space pipe space. I cannot believe that this is it. What have I forgotten? Separately, how many predators? Any helper method required to do this? Well, thankfully I haven't. I am not confident about this, but we'll find out. Okay, simulation 1, and then, so check. First they want us to, oops. Yeah, so now we see the soldiers have started spreading around, right? And then in the test case, they would like us to select a cell location nodes to soldier to place the predator, and then advance by 1 stage. So to see just the first one attacking, and then we're gonna advance by a whole bunch. So I think 3-3 is bound to be, because it's like in the corner of the nest. It's below 2-3 where there's a soldier. It's below 3-3 with a soldier. So I'm just gonna add a predator to 3-3. Predator added. Advance 1 stage. Oh no. Well, this is not working. Oh no, don't, please. Okay, my engaging is not working. God damn it. Right. If type event is soldier and it's patrolling, have I misspelled patrolling? Is that the problem? If set status to engaging and okay, type event, status engaging. Oh no, this is what I did not want to happen. Because like I'm kind of like 28 minutes in and now there's a bug and I don't know where it is. I'll just put a breakpoint, I guess, right? And then try it again. I'm hating every minute of this. Yes. You're tripping. Okay, where was I? Gosh darn it. Right. Right, let's put a breakpoint here and then run and debug. Yeah, I don't like that. Simulation number 1. Have a little look, but there should be maybe a bunch of soldier by the nest already. Yeah, happy. Can I check it in 3-3-3-2? I mean, 3-3 is close enough. I don't even know if it's neighboring, but that will do. Advance one stage. So it's not, we're not even getting into the, it's not hitting my breakpoint because some reason it's not even, oh no, wait, is it? No, we're still in the, right, so we're not hitting the breakpoint because, the exact, because that happened to me actually in the same place when I did the rehearsal. I forgot my brackets. Although, yeah, because we're not getting into it, I should have put the breakpoint above here. Well, you know what, I'm not going to even put a breakpoint. I'm going to save this and run it again and just like be confident that it will work. Wow. I did main get state. Yes, thank you. Okay, and then, yeah, just a little contretemps. Unexpected. Right, so if you just have a look at it when it's starting, all the soldiers are in the nest, and there's 4 of them because the 5th aunt is the queen ant. So there's as many soldiers as there are workers. We advance by 1 stage to get them to spread around. They're spreading around. I'm going to put the thing in, the predator in 3-2 because it's right next to the advance by 1. Yeah, no. Yes, soldier at 3-3 engaging. Cool. And we see the soldier at 3-3, which weirdly is not anymore. Have I? Oh no, it's actually moved to. It's not laid the pheromone. It lays it when as it's fighting. And then if I advance by 1 stage, no. If I advance by 1 stage, it is fighting. There's another soldier that's engaging, right? And if I advance by 5, there's a whole bunch of them fighting. Right? So by the end, they're pretty much all into the, right? There's 3 of the soldiers are in the pheromone. There's this one that just kind of got lost because he never got the chance to smell it. Now, because this is loading up pheromones onto the cell, all of the aunts are attracted there as well. But, you know, like the worker ants, when they smell a battle, they join the battle. And, you know, this is on purpose. Like they did say, gosh darn it, they did say in here, too big. Yeah, over soldier ants and worker ants on carrying food should be attracted to the pheromone as strongest around them, as the strongest around them. The emission community predator is overwhelmed. Well, I mean, at the moment, there's no interaction between any ants and the predator, but still, let's have a look at. Oh, why are you doing this? Why? The diff. Okay. Here is the, well, that's the top of it. Right, new choice 6 to, what do we do to add a predator to cell and confirm that it's got added? I define this, we need to have a predators list, that is a private attribute of the simulation class that initializes at empty. We make sure we create as many soldiers as workarounds, and this is in the setup nest at public method of the simulation class. Add predator to cell, that's the one that gets called that we've just seen, right? And this just takes new predator instance in the run column. I'm just going to, well, do I go back? Yeah, let's do them down the file as in order. So updates the pheromone in cell. We've changed those 2 because we passing a variable new pheromone strength that if the aunt in question is a soldier, the stank is 5 times more powerful. What an excitement. The number of ants in cell, same deal, we need to exclude the soldier ants. They have their own counting function, which means that in the get details, we're changing only get details, not get area details in this one, which is helpful, but otherwise we'd paste the same code in a different place. We display the predators, like, so we're always doing the same thing, which, well, no, we're not really always doing the same thing, right? So like, so far we were doing, when we did like the fire ant? No, flying ant and forager ant. It all starts in F. The F-ing ant, because there was only one of them or whatever, we check, and if it's the same location in the term cell, we just kind of display it or not. Whereas sometimes things in the same location, but there's more than one. So in that case, we need to get this is where we get this get number of soldiers in cell method we've just wrote. And then if that's larger than 0, we're going to display the number of soldiers. So far, so good. And then the big changes are in our good friend simulation.advanced method, where I'm just putting all of the existing code that really caters to the worker ends into the else clause of a big old if for if type of end is soldier. In there's 2 branches, they're patrolling or engaged already. And if they're patrolling, actually, we really ask them to move to the same way we move workarounds, except we figure out whether we have a predator in a neighboring cell, and if that's the case, right, same thing, we have to iterate, like, you loop over each of the predators, you loop over each of the neighbors, and then if both are in the same location, remember your neighbors here is actually indices. There should be neighbors indices. And so this is an index in the self_grid list. And if they are the same location, we say the index, so we make it look like there's a very strong pheromone, like to say just basically move towards that cell and change the state to engaging, print something to confirm to the user. If the ant is engaged, that is actually fighting, so it should already be in the correct cell. Like an engaged soldier ant never moves anymore. It just stays in the cell and lays pheromone, which the special pheromones, they are 5 times stronger in the cell in question. And we also here have a confirmation message. There's a green line here, which is just the predator class, which frankly, I mean, because this just takes the super, I could just do class predator pass. I think that would work. But then, you gotta put a bit of effort. I felt bad just kind of defining a new class and putting a pass in there. And then the new soldier ant class. No, this inherits the ant class. The constructor just calls the superclasses constructor, which is going to like put it in the right place, do all of the ant stuff. So ants like and this comes from entity, whether you create it, this kind of binds it, say this, it belongs to this nest. We don't pass a nest object because again it's all done kind of by location and our things in the same place. And the food capacity is 5 because they've asked us, but like we never use that. The type of event is soldier and the state is patrolling, because this __ state is a new private attribute, is that it has its own getter and setter. So far so good, and it's get state, not get status, and don't forget the brackets. And you see my panic, right? Like 28 minutes in and like you've done a lot and you think that's going to be good, and then it doesn't run, and it's like, how long would you spend to debug this? Well, maybe not that much, because in terms of the mark scheme, if you get everything but like a little bug that with the bracket, you're probably going to get all points except the testing point. So, but you don't know, if you think that if your test doesn't work, you don't know that you get everything except a tiny problem, because it could be a larger problem. So just like manage your time carefully. I'll do a video especially about sort of exam technique for the section D in particular, or the whole of paper 1. Anyway, choose cell to move to. This was just like copied whole cell from the workaround, removing all of the bits where the workarounds are carrying, have food on their back and carry things back to the nest, which means that effectively we either choose a random neighbor if we didn't get past a strongest pheromone, meaning like the one to move to, or we use the index of the neighbor with strongest pheromone. This might be an actual pheromone, or this may be the actual place where the predator is. That's it. It wasn't that bad. It was still north for 30 minutes, where I'm not super happy about it, but I think it's important for you to see that even experts like me struggle with these. So thank you very much for watching as always, and until next time, stay coding. Is that a good sign off? Keep simulating ants. That's right. Maybe we're all ants in a simulation. Maybe the universe is not just a simulation. It's like an alien A-level computer science. Wouldn't that be terrible?